Vectors. Scalars and vectors. For a person to move from one place, say A to B, he must know both the distance and direction of B from A. Quantities that have both magnitude and direction are called vector quantities, or simply vectors. Scalars are quantities that have magnitude only and no direction. For example, velocity and displacement are vectors. For instance, 50 kilometers due southeast, that is displacement. A speed of 100 kilometers per hour due northwest is velocity, and it's a vector. Displacement vectors and notation. Clearly, a directed distance is a vector. To go from P to Q along the shortest distance, we must travel in a specific direction for a definite distance. This is illustrated below. Distance from P to Q in the given direction is called the displacement PQ, denoted as PQ. It can also be denoted by a small letter, e.g. vector A or vector A bar. In print, vector AB is bold. In handwriting, we use an arrow or a waveline, e.g. AB or AB or A. Equivalent vectors. Vectors with same magnitude and same direction are said to be equivalent. Consider the lines below. MN and OP are parallel, have equal magnitude and same direction, denoted as below. We write MN is equal to OP. QR and ST are parallel, have equal magnitude but opposite direction. QR and ST are not equivalent. We write QR is not equal to ST. We have to reverse the direction of one. We use a negative sign, that is, QR is equal to negative ST. Addition of vectors. Consider the figure below. To move from A to C, we can move from A to B, then B to C. Hence, AC is equal to AB plus BC. Vector AC is called the resultant vector of AB and BC. Multiplication of vectors by scalars. Consider the figure below. AE is equal to AB plus BC plus CD plus DE. That is A plus A plus A plus A equals to 4A. Similarly, AC is 2A, AD is 3A, ED is minus A, DB is minus 2A. Also, if V is a point halfway between A and B, then AV is a half A. The values 2, 3, minus 2 and a half are scalars. Scalars can take any value. Consider the lines below. Vectors on a Cartesian plane. Consider the following. Vector AB represents a translation of the points on the plane which move A to B, that is, 2 points to the right and 5 points upwards. This is written as a column 2, 5. Generally, AB is equal to B minus A, which is 4, 9 minus 2, 4, giving us 2, 5. PQ is Q minus P, which is equal to 11, 1 minus 7, 4, giving us 4 minus 3. Therefore, PQ is equal to 4 minus 3. Consider vector MO. We can have MO is equal to O minus M, that is 12, 8 minus 6, 7, giving us 6, 1. Therefore, vector MO is equal to 6, 1. Alternatively, MO is equal to MN plus NO. MN is equal to N minus M. 9, 10 minus 6, 7, which is equal to 3, 3. Therefore, Mn is 3, 3. NO is equal to O minus N, that is 12, 8 minus 9, 10, giving us 3 minus 2. Therefore, NO is 3 minus 2. Mn plus No is 3, 3 plus 3 minus 2, giving us 6, 1, and we arrive at the same answer. Vector written as AB is said to be in column form and is called column vector. Position vectors. The position of a point on a Cartesian plane is given with reference to the origin. Consider the Cartesian plane below. From origin O, P is 3 points on the x-axis and 4 points on the y-axis. P has coordinates 3, 4. And OP has column vectors 3, 4. Equally, Q has coordinates minus 5, 1, and OQ has column vector minus 5, 1. OP and OQ are known as position vectors of P and Q respectively. For example, if OP is equal to 3, 4 and OQ is minus 5, 1, find coordinates of P and Q, column vector for PQ. In our solution, OP is 3, 4, therefore P is 3, 4. OQ is minus 5, 1, coordinates of Q are minus 5, 1. PQ is equal to PO plus OQ, which is equal to minus OP plus OQ. This is also equal to OQ minus OP, that is minus 5, 1, minus 3, 4, giving us minus 8, minus 3. Midpoints. Consider the figure below. O is the origin. OA, OB, and OM are position vectors. AB is equal to AO plus OB. That is minus A plus B, or B minus A. M is the midpoint of AB. Therefore, AM is equal to MB, which is equal to a half AB, which is a half into vector B minus vector A. Therefore, OM is equal to OA plus AM. That is A plus a half into vector B minus A. This gives us vector A plus a half vector B minus a half vector A, giving us a half vector A plus a half vector B, which is a half into A plus B. If A is 5, 5 and B is 3, 1, then OA is equal to A and is given by 5, 5, and OB is equal to B and is given by 3, 1. OM is a half into 5, 5 plus 3, 1, giving us 4, 3. Generally, if A is AB and B is CD, the midpoint M of AB is given and has the coordinates A plus C over 2, B plus D over 2. Length of vectors. If AB is equal to 6, 8, it means that starting from A, you cover a distance of 6 units in the horizontal axis and 8 units on the vertical axis. This can be represented as shown by the figure below. By Pythagoras' theorem, AB squared is equal to AC squared plus BC squared. Thus, the length or magnitude of AB written as this is given by AB squared is equal to 6 squared plus 8 squared, which is 100, and the answer is 10 units. In general, if P is XY and Q is AB, then PQ is AB minus XY, which is A minus X, B minus Y, and the answer is square root of A minus X squared plus B minus Y squared. Example: if A is 3, 2 and B is 3, 4, AB will be, find vector AB, which is B minus A, which is 5, 4 minus 3, 2, giving us 2, 2. AB is equal to square root of 2 squared plus 2 squared, and the answer is square root of 8. Note that magnitude OA plus magnitude OB is not the same as magnitude of OA plus OB. Generally, magnitude A plus B is not equal to magnitude A plus magnitude B. Translation and displacement vectors. Translation as a transformation. Consider the figure below. Figure ABC is translated to A prime, B prime, C prime by vector A. The points move distance A from the original position. A prime is A plus vector A, B prime is B plus vector A, and C prime is C plus vector A. If ABC is on a Cartesian plane and A is 3, 4, B 1, 2, and C 2, 0, then A prime, B prime, C prime has the following coordinates and translation with displacement vector A equal to 2, 3. A 3, 4 plus 2, 3 is equal to A prime 5, 7. B 1, 3 plus 2, 3 equal to B prime 3, 6. C 2, 0 plus 2, 3 equal to C prime 4, 3. The coordinates for the triangle will be A prime 5, 7, B prime 3, 6, and C prime 4, 3 on the Cartesian plane.
One of the wonderful things about mathematics, I think, is that people are impressed. It's often seen as a very hard subject, and so if you've done math, it's often treated as an entrance requirement, as a credential to do lots of other things. And so one idea is that for example, some MBA programs, the only thing they require going into it is a good, solid math understanding. They can teach you all the business. They just can't teach you the math fast enough. And so I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as a filter or as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.